Let's see. Are we recording? Anybody know? How do I know? Yeah, that button means we're recording. Hey, great, we're recording. All right. That's the beauty. So, I'm glad to hear that nobody has read those chapters. For the first time ever, you haven't checked those. Like, I'm glad to hear no one read the chapters.
I'm surprised everybody was honest.
I know. Yeah, glad to. I found most people are pretty honest about that question. Then, like, I can start asking you questions about it. They're like, oh, sorry, I actually. So one of the reasons for not doing it today is I did take a look at those chapters more carefully. And they actually start getting into some really cool ideas around how you approach engineering problems. And I thought, let's not do that today before a big exam. Yeah? I didn't want to like rush through it, be like, oh, this is a while loop, this is indefinite loops, done. Okay, bam. I actually wanted to sit down and show you the examples. Some of the feedback I got from you was let's do more examples. So that's another reason why we're not going to do those chapters today. We're going to do a bunch of problems today. Hopefully that's all we do today, is talk about concepts that you don't feel comfortable with, that we've already done, and do a bunch of examples. So that's kind of it. So homework 6 questions. If you have any topic we've already discussed. Okay. And then I think what we'll end up doing is if we don't have too much to talk about here, we'll go over to the computers and I'll show you a set of practice problems I did make for the exam. And there's a lot of them, and I'll talk about my expectations. We're not going to do all of them, but what I wanted to give is a variety in terms of the complexity of the problems that are there, as well as a variety in terms of the breadth. Because there's a lot of topics we've talked about. There's a lot of ways you can integrate the topics we've talked about. And I think that may be one of the more challenging things for us, is how do we integrate for loops with conditionals? How do we integrate file reading with iterative operations, right? And that's ultimately, that's where the power of this computational stuff comes from, is being able to integrate these various features together and do something cool, right? So hopefully that we'll spend more time over there. Maybe, maybe we'll just actually do a couple problems all together, or maybe you guys can just go off on your own and do it. Whatever you guys want to do, I'm open to that. That's roughly the plan for today. Cool? Okay. Next week. Yeah, so sorry, exam 2 is next week.
2 hours?
Yeah, yeah. So last exam we had 4 problems. I do not think I'll be doing 4 problems on this. I'll do less, but I think the complexity of the problems will be a little bit more than last time. Okay? Now the challenge I have here is creating problems where it's not full jeopardy. And what I mean by that is, if it's a complex problem, sometimes it's like, you get to a place where like, I can't do it, and you lose all 60 points, right? And I don't want to have an exam that's like that, right? And so in the past, what I've done is had too many problems on the exam in the spirit of wanting to have some problems that are easy points and some problems that are hard. So what it might end up looking like is there's 2 or 3 problems, but there's phases to it. And hopefully I can make the phase like part 1 digestible and be like, okay, I got phase 1 done, I can't do phase 2. That's kind of my hope. If you have some thoughts on that, I'm all ears, but that's my plan. I didn't do the phasing for the practice problems. There are a couple of like what I call bonuses on there. Maybe those will become extra credit type things on an exam. I don't know. Cool. All right, so someone did ask when the exam was. So next week will be exam 2. Okay. We will do lecture after exam. I want to focus on the chapter on loops. There's a chapter in Han called loops, and this has gotten me really frustrating for me, is that the chapter numbers have changed quite a bit from these editions to editions. So there's a chapter called loops. It goes a little bit more in depth. You have the same version I do, I think. This one? Yeah. I think that's chapter 8 in that book, but I don't know what it is in the newer one. Felipe, you have the newer one? I know, just chapter 8. Yeah, chapter 8 loops, and then the other one it's. That's the newer one. Which chapter is it in there?
It's 8.
It's day 8. Great. Okay, chapter 8.
Example,
yeah.
It's a real one.
Yeah. So it goes into loops and kind of like how you use loops for engineering problems a little bit more. We talk about definite looping and indefinite looping, which is a structural thing, based mostly on the problem you're trying to solve. And we'll introduce the while loop, which I know has come up in conversation earlier, but we haven't really talked about. That'll be after exam 2. The topic of logical vectors, I think I'm going to defer for a little bit. So we might come back to it later. Okay. That was chapter 5. Yeah. Cool. And then the week after that, so that's March 21st. Yep. Yeah. So this is next week is March 14th. And March 21st, we will do the matrices. And then the week after that is spring. Cool. Okay. So let's start with this guy. Any questions on? Oh, sorry.
Homework 6, yeah.
Oh yeah. Okay. Let's start with homework 6. Any questions?
So for the bracket, I was able to get it fine, but when I stretched it open to the size that you had on the example, I noticed the resolution wasn't like the same as yours. So I was trying to mess around with like smoothing functions, but I couldn't get it to really work that well. I was wondering if there anything you know that would like improve the resolution.
Okay, maybe you can clarify for me what you meant by when you zoomed in.
Not zoomed in, just when you had an example picture on the,
Yeah, it was
when I stretched out my window to top left for the plotting to the same size, I noticed there was little dots in between missing here and there, and it was like a little jagged around the corners. It didn't look as smooth.
Oh, interesting. So I definitely did not do any smoothing. Mine was discrete points that came out of the equations. Sorry, that was in modules.
I did that. That's what I mean. I did that.
Oh, I didn't.
I went to like 10 or 100 million. Oh. But it hit a point where like adding a 0 didn't do anything more. Yeah.
So this does look very smooth. Is that what you mean?
Yeah.
But if I zoom in, it doesn't. You're not going to see that smoothness. Yeah. In fact, here.
I didn't know if there was like something that you did special to make it like that or whatever.
No, that's a great question. Shoot, it's on my key on my laptop.
Okay.
Well, okay. Look, before I go and just get distracted by that, what other questions do we have for homework 6? There's got to be some. Who has a piece of code that didn't work that would love to see it work? Everyone got it to work? Awesome.
The hell thing is.
Yeah. I guess my question is, what aspects of this homework would be on the exam?
Yeah, the ability to solve a problem iteratively. I would like for you to be able to do that. To be able to use subplots effectively, that would be good too. I think those are the two main things.
Like that was like what problem 4 was like to say adding subplots effectively, right?
I think problem 4 was the only one that had subplots.
Yeah.
Is that right?
Yeah.
Well, actually, I mean, just to add to that, just in general, being able to use the various attributes to plotting, so a line versus a dots, color selection, those kind of things. And, ultimately, we are going to get to a place where oh shoot, sorry about that. Ultimately, we're going to get to a place where I don't want to have to specify all that stuff, right? I'm just basically going to count on you to start using some of your own judgment for like what should be a line versus what should be a dot. And we can talk about that more, but yeah. And you'll see that in the practice problems for the exam. I'm getting less sort of specific about things.
Like, what would you call all the symbols for plot that way?
Yeah, what does MATLAB call? Let's just do help. I think they're called markers. They don't actually say here, but that's what I think that's fair. You can call these the markers. You can call these the colors, and these are either your line characteristics.
So symbols? No. Plot symbols and colors.
Oh yeah, sorry, they're called symbols.
Oh.
Thank you.
Oh, sure.
What was the iteration stuff?
Yeah, so iterations were like 2 or 3 of our problems were involved iterations. Oops. Oops. right, let's actually start with this one. How many of you did this with a for loop? Okay. And how many of you did it through vectorization? Okay, cool. So we have a good set of sample here that you can do it both ways, right? And this is what I mean by more often than not, I'm going to start saying, I don't mind if you do it with a for loop or vectorization. In a way, they both exercise different skills. One could make the argument, hey, you should do it with vectorization because it's MATLAB. Another person can make the argument, hey, you should do it with for loops because you're not always going to have vectorization. Right? So I think those are both reasonable things to ask, and I'm okay with you doing it either way. There are specific cases where I will ask, but I'm trying to move more towards not being so particular about how you accomplish it. Would we, for those of you, like, let's think this question. Would we think of this as being an iterative problem? What do you guys think?
What do you mean by iterative? I'm trying to refresh it off the top of my head.
Okay, can someone give us a definition?
Is that for loop?
I was using them synonymous, but I don't think this is iterative. I think problem 2 and 3 are iterative.
Yeah.
And this one, I don't know what the term for it would be if it's not iterative.
Great, great. Okay, so we got some identification of what it is it iterative or not, but we still don't know what iterative is. All right. So I think a really simple way to think about iterative is if there's something that repeats. Okay? The repetition could be over time, or it could just be over an increasing value, or it could be, let's say in this case, a population that grows.
So this is iterative. Because, okay.
No, let me go there. So typically when we think of iterative, what we're saying is what happened in this moment influences the next moment.
Yeah.
This next moment, what happens in this moment then influences the next moment, right? And in a way, what you're saying is, if I wanted to just figure out what happens here, there's no way I can just go straight to this spot. The only way I can do it is by first figuring out this step. That answer helps me with this step. That answer helps me with this step. That answer, then I can get to this answer, right? And that's the only way I can get this value. That's an iterative problem. Okay? No, just one second.
Oh, sure.
In here, if I ask you, what is the population in the year 2000, you can just plug the year 2000 into there, and bam, you got the value. You didn't have to go from year 1 to 2 to 3 to 4. You go straight, you put the value, so not an iterative problem. Okay? You have a very nice function that defines your relationship or your curve, and you go bam, you got it.
So then I would say it's not iterative.
Yeah, so this one's not, we would say it's not iterative. Yeah, just.
Oh, so in problem 1, each point is independent, almost in a way, and then for 2 and 3, they're all self-referencing one another, I guess.
Yeah, that's certainly one way to do it. Yeah.
They're dependent on themselves.
Yeah.
They're dependent upon previous
Previous
information.
values.
You can't just go to like value 4 without doing 1, 2, 3.
Now, to be clear, there are problems that appear iterative first, and at some point, somebody does some complex math and gets you to a solution where you don't have to iterate. That happens, but let's not go there, right? But you might encounter those kind of situations in the future. And in fact, a lot of computational problems that do appear iterative, this is what computer scientists get paid to do. A lot of computational problems that look iterative, which if you think about it, that takes a lot more compute, because you guys compute here, next step, next step. They do some complex math, they're like, whoa, I found a shortcut to get to this value without doing all this other stuff. Right? And the equation might look completely different, completely chaotic, completely. And they basically turn an iterative problem into a, I don't know what the right term is, but a non-iterative
That's like all of math, isn't it?
problem. It's a lot of computer science for sure. I don't know if it's a lot of all of math, but maybe it is. Yeah, computer science is math. Okay, fair enough. You get it. Okay, so then let's look at this one. Mathematical chaos. What do you guys think about this one? I mean, I tell you it's iterative, right?
So what I noticed is a lot of people are having issues with determining how to decide on numbers, like initial values,
Okay.
and what the overall expectation of the program should be, because it seemed rather simple. And so people were skittish to think they were finished.
Yeah. What do you mean by overall expectation?
Like, so it kind of says, well, here are some numbers that, and, you know, but it doesn't say these values. I don't know. Are we supposed to use the values that are there because they're within example type
You mean these
sentence
values, right?
structures? Yeah, those or why initial, you know.
Yeah,
I explored a lot of
reasonable
values, and I realized that yours they're within a range that actually starts to make the problem make sense.
These ones or these
Yeah,
ones?
both.
Yeah. Yeah. Well, that's fair. So one of the challenges with this problem, and I think the next one as well, is they are more of this mathematical abstract problem where they're not dealing with concrete values in the real world. So what do these numbers mean? One thing. And what are reasonable values? That's a reasonable thing to suggest. I think, you know, this is giving you this is definitely giving you something to work with, right? To say, like, these are interesting values. I guess the solution, the initial values here don't tell you really where to start. Yeah. I don't know if there's a clear answer. Like, did you try
I
figure
found
why
that
it
beneath
was?
one, anything less than one worked a lot better than things above one.
And what happened when you went above one?
It turned into just like a line that sometimes it has
So
certain
it's less-
structure.
became
It
less
was way less interesting. It would either be like a straight line somewhere or a line with a bend in it.
That's fair. Now, was your code written in such a way that that was relatively easy to do? To try different values for a while?
Yeah.
I wrote a program that made it very easy to do because I was curious. I was like, what
Yeah.
happens? And I didn't want to type it all in, so I just I did random between certain values, and I just watched what it would do every time.
Yeah. So that's definitely like when you have a space. So this is what, you know, you can think of this as like, here's a problem, and I actually don't know what's the right term. I don't know the reasonable space of values to operate within, right? And actually, a lot of engineering problems do come out this way. Like, what are your reasonable space of initial values? What are reasonable space of large? Like, what is the max value I should explore? What's the min value I should explore? Yeah. You know, I think if it was a more concrete problem where I said this is a power system circuit, you go, okay, well, I know it's going to be at least this many volts or whatever. And this is just random numbers out of it.
So is that your idea, to make us explore, define like the limits and range of what
I
numbers?
mean, that's certainly part of these 2 or 3 were very exploratory. Yeah. I wasn't expecting you to create the random function in a loop, but it's fairly straightforward. This is the beauty of MATLAB. It's fairly straightforward. Just try a different value for a while. And you would not, you know, this problem doesn't actually ask you for a result per se.
Mm-hmm.
It just says, build this function, try out these numbers because they look cool.
Okay, yeah, it's cool.
Yeah, initial values and expectations. Yeah. So let's start. Is this iterative? What do we think?
No.
Yes, absolutely.
Oh, ignoring what I said. Ignoring what I said.
Oh,
why is it iterative?
The result or the numerical value that is in the equation is the starting position of the series.
Yeah.
And the value of the equation is the next position in the series, which then switches to be the value in the next iteration of the equation.
Yeah. So one kind of like clue that you may be dealing with in an interrelationship is when your equation, your function that defines what you're dealing with here, has subscripts that have different indexes. That's typically one clue, right? So what I mean by that is we've got the subscript k here and k plus 1. So that's saying that's a before and after, or earlier in the series, later in the series, however you want to think about it. I mean, technically speaking, we use before and after. In reality, there's that time component may not really exist here. Like in this function, there's no such thing as time, right? So we can use before and after. I think it's convenient for us, but just know that that's the case. How many people used for loops for this? Could you solve this with vectorization?
I tried, I couldn't.
Yeah.
I want to know how the.
I don't think you can.
Okay.
I don't think you can. Isn't it?
I always initially start with vectorization.
You did start with vectorization?
I always do.
Always did? Yeah. And you eventually got
Because I didn't feel comfortable with for loops, but
Yeah.
now I think I'm feeling better with for loops.
Yay! That's good.
It took a while.
That's a good sign. Does anyone want to talk about this one more? Yeah.
I was trying to make it so it will plot 7 graphs, and also you can input like different types of R.
Oh, cool.
Like using the for loop,
Yeah.
but I didn't make it work since I was thinking of storing, for example, let's say y equals all these data points. And
Yeah.
apply those to all
That's
the
awesome.
ways They work out.
Ah,
Yeah.
do you have your code?
You have
Yeah,
to
I'm
index the subplot, let's do that.
Let's check it
Can I
out.
check it out? Or,
Well, if everybody else wants to.
Yeah.
I thought about doing that, but it would have been more work.
yeah, I tried it.
I think you just gotta leave up right there.
That's right, I made it so you can't put like.
This is the guy who did a random function to explore the valid initial conditions. It's Jorge, right?
Yeah.
Can you send it to me?
Or
is it-
I submitted it.
Oh, you submitted it?
It's inside of, yeah.
Wait, it doesn't
That's
work?
common.
It doesn't work and you submitted it? That's awesome.
I mean, I didn't know it.
That's awesome. I mean, I'm okay with that.
It's some points, right?
For sure.
You wrote really good code and then you messed up one line.
No, I mean, like,
So everybody-
no, what I mean is, like, I'm sure you had a regular one that worked just fine.
I mean, I did one that plotted the 7 graphs. But
Okay.
I had to like do it individually.
Oh, I see. Okay.
Yeah.
So this was, which one was that? Was that 3?
2.
2, sorry, okay.
Yeah.
This file? Yeah.
Yeah.
All right.
Oops.
Oh, interesting.
It looks
Ah. All right, so. Let's see. Are you guys okay with the lights on, or do we want to dim some lights? How about I just dim the front? No, I'll just dim this front set. Yeah, sorry, I can't dim it. I can turn it off. This is 100% dim. 100% dimming. Okay. Cool. Is that font size okay?
Yeah.
All right, great. So, okay, we're.
That's one way of doing it, but if you go, please scroll down. Down. Yeah, exactly.
Oh, I see what you did. Okay, great.
So if you delete from X2,
Wait, so wait, help us understand what you did here, because I think this is cool. I want to understand what you did. So, you've got a bunch of initial variables, right?
which is the same thing.
And are these intended to be the
Different
initial
ones so
values
that, yeah,
for
I
the
get
different
sketches? Yeah, different graphs for.
different scratches, graphs? So you're doing 8 total.
Yes.
Cool. Okay.
Oh,
And
there's
then,
7. There's 7.
oh, sorry, 7. Yeah, yeah. Okay. And this is, what is this defining for us?
The number of points I want.
The number of points you want
Max
Yeah,
iterations,
yeah.
the amount of
Iterations, yeah, I want to do
in the for loop.
in the for loop. So we'll make.
How many of you had this as a variable in your code? Should all have it as a variable in your code. Okay? Please don't define it in your for loop. Make it a variable. Why? Make it easier to change. There will eventually come to a point where you start writing pieces of code where you're going to use this value many times. In fact, do you use it many times in here?
Well, I will check it. Yeah.
Or just once?
Yeah,
How
I use it
often-
like for every for loop. Yeah, I have to use max iterate.
Yeah, and so you have multiple for loops,
Yes.
right? So let's see what that looks like, right? What that looks like down here is there's a for loop for each of these plots, right? You guys see that? And for each of them, he goes from IT count -1 to max iter, right? And he's got max iter as a variable throughout, right? Imagine if you decided, 100 just wasn't working for me. I need to do 200, right? If 200 was being used directly in the for loop as a value, you would have to change it in all of them. You'd have to change it, make sure you don't make an accidental typographical error while you change it. Make sure you don't forget that, oh, there was another location down here I need, right? So this is beauty, like the beauty of computing is to take advantage of these variables, right? Make your code as dynamic as possible. This is a perfect example of what I mean by that. So, is everyone okay with that idea? Why do you want to do it? It seems like a pain sometimes, but it will pay off. You'll have dividends at some point. Okay, so back up. Sorry, that was a distraction. Yeah, sorry to distract. Okay, then what do we got here? What's this one? The R values or yeah. Okay, so these are 8 R values. Sorry, 7. Can't get my count. These are 7 R values that correspond to the 7 initial values. Yeah. Okay, very cool. And then what do we do?
You copy down the equation and now.
So what does this equation represent?
So for x, for example, let's do the first one, x of 2 will make equal r times x of 1 times 1 minus x of 1.
Got it. Okay,
That
so
will
this
store the
is
values
if I think of k's
Yeah.
for just a moment, because that's what the equation had, the original equation had k's, right? This is k, and this is k plus 1. Is that right?
Yeah.
Okay, cool. And what does IT count stand for? Just so everyone knows.
The iteration number.
Iteration count, right? So it's like the k. It's exactly like the k. You know, in a problem like this, maybe you could get away with k because it's not really meaningful to us. I like iteration. Personally, I like iteration count better. But you will get to a point where the problems you're dealing with, the iteration has some meaning. And you want the variable name to sort of correspond to what that meaning is as it's iterated. Cool. Okay, so and then why do we have 7 for loops?
7 for loops because we want 7 graphs.
7 graphs, right? 7 for loops, 7 graphs, 7 vectors, 7 initial values, 7 R values. Good, great.
Wait a minute. This is problem what? Number 2?
You didn't need to do all 7.
Oh.
No, you only had to do 1.
Couldn't you do all that in one loop?
Maybe.
I'll try to do
This is what he's trying to do. That's what we're trying to get to the bottom.
Yeah.
Yeah. Hang on. So this was for this problem. You only had to have the code do it once, and you could try different R values. You could try different initial values. And what Jorge was trying to do was let me try a bunch of them all in the same piece of code. And so that's why he's got so many for loops. He's just trying to do. You were trying to replicate that one plot I had, basically, right? Yeah. So if you remember on Canvas, I posted this thing. Why is it sideways? Yeah. So you were basically trying to recreate this thing, right?
I actually got it, but yeah, using that way.
Ah, yeah. Cool. Okay.
I also tried for the pane. If you feel like I want that graph to be in pane 7, like for example the last one, I was trying to put it like in the middle, like 7.5, but it actually extend the graph like, in different sizes.
Oh yeah. That's actually a feature. But maybe it didn't turn out the way you wanted.
Yeah, they turn it.
But it's a feature because that allows you to mix wider plots with narrower plots. Which is actually handy sometimes, depending on what you're trying to show. Okay, cool. Back to your code, right? So then what do we do?
Subplots.
Okay, so for each of those vectors that we did a for loop and we calculated iteratively, we have now a subplot, right? And people remind us, what does this 4, 2, 3 mean? What does that mean?
Forward, 2, row,
Yeah, row column,
Yeah.
and then the panel number or pane number, right? Yeah, exactly. And how do we count them?
Left to right.
1, 2, 3, 4, 5, 6. Yeah, cool. Yeah, great. Everyone's. I have to acknowledge that subplot is a weird thing the first time you start using it, right? Like the way it's constructed and how you have to use it.
I couldn't figure it out. It took me 10 minutes.
You're not. Welcome to everyone. Everyone who ever reaches subplot is like, what the?
Yeah.
What? Yeah. But what? You guys are okay with it now?
Yeah.
Like if you need to do an exam?
Oh, yeah.
Great. That's awesome. Oh, the whole exam is going to be subplots. Okay.
Help subplot. All the syntax is like h equals subplot.
Yeah.
And why are you assigning the subplot to a variable?
Okay,
People
so-
don't understand the syntax of that.
Yeah.
It's very strange.
So we really try to avoid that till later if we actually even need it. But all of the visualization in MATLAB has what are called handles. They they are effectively objects. And if you want to basically be able to manipulate that object again later, you can use that handle.
Interesting.
So by saying h equals subplot, you've now given a handle that you can then reference that subplot anywhere on later on in the code to modify. But it's a complexity that we don't need to deal with.
But that's what they're talking about when they're saying object-oriented.
In a sense, it is an object. It is an object in the MATLAB world. I wouldn't go as far as to saying it's object-oriented. Because object-oriented is a whole philosophy around how you solve problems. So it's not really the way MATLAB does most of it. What we're doing here is really procedural or functional programming. I think towards the end of the semester, we'll talk about objects and how object-oriented, how you might approach an object-oriented program, just so you can sort of see, oh wow, that's how different it is. This is very different.
I saw this whole thing in 2 for loops.
Yeah.
Nested.
Hold on, we're getting there. Any questions on this? No? Okay, let's look at the loop part. Shall we do that? Okay. And you're saying I could just delete all the stuff on the top here?
Delete from,
Here?
can you go on top first?
Can I just go from here up?
Yeah, you can do that.
Okay.
Up to x2 of 1.
Right here?
Yeah.
Is that correct? I delete all that?
That works, yeah.
Okay, and then uncomment this
I'm
stuff?
comment all that.
No, that's a comment. I need to keep
Yeah,
that.
that's comment, yeah.
Control R.
Yeah, I don't remember. I'm used to control / which is a different ID. If I do that right now, I'll probably break something. Okay, cool. So let's see.
You may also delete x1. It's also repeating.
This one?
Yeah.
Okay. Does that look good? Yeah, okay. Shall we take a look at the approach here and see what's going on? So we have this max iteration variable again, perfect. Then we define an initial x1. And then we have a vector. Nice, good. So when you want to do a variety of different things, a vector is often a good way to store that input data. So we've got a vector of r's. And these correspond to what we saw above, right? When we had R1 parentheses 1 equals R2. Okay, good. Okay, so then we got for
Different R.
oh, different R. Okay, for each, in a way, what we're saying here is for each value in the R vector. Is that fair? Yeah. Okay. You mind? I'm just gonna. Well, it's not your. It's my code now that you delivered it to me. I'm just gonna write. Okay. So this is basically saying, go through each R value. And I'm annotating this just for here, for class. I wouldn't necessarily think that you need to do this for an assignment, right? But this for statement is basically going to go through each R value one by one, right? Is that right?
Mm-hmm.
No.
This PR.
I actually forgot a line of code.
I mean, it does, right? So, okay, this is a stylistic thing. It depends on how you want to do this, okay? This actually goes through the R, it goes through a new vector starting at index 1 and ending at index at length of R. So in this example, what does that look like? That looks like, it really looks like this.
Yeah.
Right? But, and that's okay because we see how we use it later. But I just want to be clear because MATLAB does allow you to just go through each value one by one. You guys remember that, right? So you have this opportunity in MATLAB that you don't have in every programming language, which is to actually go through, have your for loop just go through all the values in the vector one by one, which is a MATLAB coolness. What we have here is a more of a traditional way of doing it, which is going index by index. So saying, go from 1 to 7, and then I'll figure out what those real R values are later. Does that make sense? Mm-hmm. Maybe I didn't say it very clearly.
Seems redundant to me.
Which one's redundant?
Why you have 2 for loops there? I can't you just
No, because I'm missing one code there, but it's basically 4 parentheses, if R equals, and then I forgot the code. It was
Oh, that's okay. Hold on. So you're jumping ahead, which is great. Hold on. I just want to make sure we're on the same page with this different ways of creating your for loops. Okay? And I know where you're going to, I think, but I'm not sure. So what I'm basically saying is, your for loop, your for loop can go through either it can go through a set of values that looks like this, or in this case, what are our values? You could go through a set of values that look like this. Right? And you kind of have the option. Do you want to go through the actual values you care about, or do you want to go through the indexes? That's one way of doing it. This is your indexes, and this is your content. Which method have we chosen here? The indexes. Oh, sorry. For this one, it's the indexes. That's the index. Yeah? Okay, good. So if you choose the indexes, you just have to make sure you know that as you go through the rest of your code. Yeah, good. Okay, so let's go to the next one. What does this for loop do for us?
The iterative calculation.
It's doing that iterative calculation. So this is basically the same as the for loop that we saw 8 times before, right? With some adjustment, right? What's some adjustment? So we have that iterative count. This line looks basically the same. Okay? And then we do that iterative calculation step by step. What's the one difference between the way it is here and the way it was above?
The index in the R.
Yeah. So in the previous example, if you remember, I shouldn't have deleted it now. Huh? Did I save this already? I didn't. Yay. So if you remember, in the original version, we had all these different values of R, right? And what we did is, the first time we went through, we used R. The second time we went through, we used R2. The second time we went through, we went R3, right? Everybody okay with that? Okay, I want to ask another question just so we're super clear. Is this a vector of R?
No.
No, these are completely independent variables as far as MATLAB's concerned. And so you want to be careful that you don't start, just because you named it R7, you don't think it's the 7th element of a vector R, right? These are completely different variables. Cool, okay, so back to our code here. Whoops, where is it? There it is. Yeah, there we go, okay. So that's, what this does for us now is it takes the index that we picked out, it goes back to that vector that has all the R values and said, hey, give me this index, whatever the data is at that index, that element. Yeah? Cool, great. So we end, and then what do we do here?
Actually, wait, at this first end, I forgot a line of code. It was supposed to be Y.
Hold on. So you want me to add some code to this?
Yes, but actually forgot.
Right here?
Yeah, so Y, parenthesis, if R.
Okay.
Close parenthesis equals, and then I forgot what I used there, but I can't recall.
So help the class help you. What is your goal? What are you trying to accomplish here? Algorithmically.
The first one, if R1 colon length R, will make an iteration 7 times of the iteration of X. So first, the second for loop will create like a graph for all the points with R1, which is 3.3. And then after that finish, it will iterate if R equals 2, and then we'll create another set of points, and then if R3, that's it.
So you're storing the
The
resulting
graphs and
values?
results, yes.
Ah, okay, so that's the key. So algorithmically here, you're wanting to store the results of what you calculated here. Is that what you're trying to say?
Yeah,
okay.
Y1, Y2.
So what do you remember what this might have looked like? Can I take a guess?
Yeah, something with about X.
Yeah, exactly. Did it look like this?
I think so, yeah.
Yeah?
Oh, yeah.
Okay.
But then, yeah.
Yeah?
Yes, yes.
Okay. Any guesses as to what happens?
Aren't you trying to store an entire vector in one position of that?
Y1 will be all the, yeah.
Yeah.
I think that's
Did you let's
Y equal to X?
okay, so what I want to do is this. Yeah. And
Yeah.
But it
But
will
then
display.
somebody do the suppress the Y diff for equals X.
Yeah, okay, so. I'm sorry, what were you saying, Felipe?
I was just gonna say, suppress the setting Y different R equals to X, and then display Y, right?
Yeah, that's right. Okay, before I do this, I want to respond to Joe's thought about this appearing to be redundant, right? So what we have here, what do we call it when you have a for loop inside of a for loop? What is that structure we call it? Nested for loops, right? So, you know, think the one thing inside the Russian doll thing, right? It's one thing inside the other. Those are nested for loops. You can nest for loops 200 deep. Well, what we're saying here is that between here and here, that's going to happen some number of times, okay? And our goal here, between here and here, is every time that goes through, we're going to go to a new value of R0. Sorry, a new value of R. We're going to just do a different value. But beside that, we have to do the iterative calculation, right? So we need a separate for loop that handles this iterative calculation. That for loop is going to run many times, right? So that's why this is indented a little bit and is inside of this. So what happens here is I take a value of R. Let's take it's the first value of R. So it's 3.3. R is now 3.3. And then it's going to do this iterative calculation 100 times using R as 3.3. It's going to get here. It's going to be done. Okay? It's going to go back to here. And now it's going to say R is 3.5. With the value of R being 3.5, it's then going to, it's as if it's starting from scratch again. It's going to do these 100 iterations using R equals 3.5, etc. Yeah? So that's the goal here, is actually basically do this calculation 7 times without having to repeat this code 7 times like we did before, right? Like, oh, in the original here, we basically had that same for loop. This is actually perfect. Right, this is great. We've had that for loop 7 times here, right? And if there is a way for us to figure out how we can write our code to this, in our code, this is only occurring once, but it's executed 8 times in the 8 different ways we want it to do it. That's way better, right?
So let's go back to the code. So when in doubt, do start to use these displays as a way to debug, right? It's a good way to just get some data out and see what the answer looks like. Sure. So shall we run it and see what happens? What do you guys think? No one's excited to run it.
No, we're excited.
Oh, okay. I was getting worried here.
We were flabbergasted silent.
Yeah. Oh boy. Oh.
You haven't created a vector for Y yet.
Did you get this, Sarah?
I think I created a Y in the beginning, but I forgot to include it.
Okay, so let's do that. So how do we? So this is great. Like these are not, you know, as you have learned, the warnings and the syntax errors you get from MATLAB are not always like very prescriptive on how to fix it, right? They just kind of give you the best that MATLAB can do behind the scenes, and it's basically saying, okay, unable to perform assignment. Okay, assignment is an equal sign, right? Because the indices on the left side, these things, are not compatible with the size of the right side, this thing, right? I actually think we're in a different place than the place.
I don't know. I just that's my guess.
But let's try this. Okay, so Felipe thought, well, it's because Y is not defined as a vector yet. So let's go make Y a vector and see what happens, right? I don't think that's the error. I could be wrong.
We would need to be adding to the vector.
So here's a way to define our empty vector, right? Have you guys done that before?
Yes.
Define an empty vector, okay. Good, and we go here.
Yeah.
And
Like
okay,
concatenate.
same thing. So the problem here, exactly, yeah. It's actually exactly what it's saying. It's saying that the way you have the sort of indexed this, the way you're telling me to put it in this thing, doesn't match this thing. Okay, and let me try to help see if we can figure that out, right? Like if I will, let's if I may, let's try this. Okay, I'm going to just do this. What is the first value of diff R? It's 1, right? Just Y1 equals. I'm just going to make it 99 for fun.
-1.
Oops. What am I doing here?
Yeah, 26.
-1.
Let's do that, and then what I want to do here, do disk x, disk. See if that works. Yeah. Okay. Cool. Oh, that didn't go down. So all I'm trying to show here is a way for us to kind of, like, if we get that error, how do I go about debugging it, right? So let's just have MATLAB tell me what these things are, or how big they are. Because clearly it's telling me something about its indexes. It doesn't like the indexes, right? So I'm saying, okay, I'm doing this to just plant the seed here. I'm saying x1 has some value called 99, and then I'm saying, hey, tell me what x and y are. And the reason I'm doing that is because here, that's exactly what you're doing here, right? Y1 is different. And if you run it, you see that x has how many columns? 101 columns, right? And y has how many? 1, right? And so what MATLAB is complaining about is saying, hey, how do you expect me to put these 101 columns that are here into this one column here? That's effectively the complaint in more human speak, right? So that is a challenge. Before I move forward, how do we understand what I'm trying to say? Like on this hand, on the right hand side, you've got a vector with 101 columns. On the left hand side, you've got a vector, but you're saying put it in one column location, in like one spot in my vector, and you can't do that. It's like the box is not the right size.
Can you show us what x and y equal again?
Sure.
Is that a function essentially?
No, these are just the vectors.
X is all of those numbers above.
Yeah, x became a big vector thanks to this guy, right? That for loop built x1, x index 1, x index 2, index 3 by going as it ran. Right? So one way you can think about it is let's just imagine this is the first time we get here. Okay, first time we get here. X. What is an x?
Right now?
Yeah.
Oh.
The first time we just got to here. First time we ever got to this part of the code. There's nothing in x, right? Like if you look up there, x is never assigned a value, so x is empty.
Didn't you say like x position 1 is something?
Did we? Oh, I'm sorry. Okay, if we did. Okay, yeah. My apologies. Did we do that?
Yeah.
Yeah. Okay. Sorry. You're right. So x has 0.2. Thanks for catching that.
Yeah.
Okay. So now, first time I'm here, this is the total contents of x. You okay with that?
Yeah.
What happens after I execute this the first time?
It fills that.
They just
They've never iteration.
The whole loop?
No. The first time I go through this loop,
Oh, that's the second.
it has the next value. So whatever the number is, the second value, that gets put into here. And that's the full size of the vector x.
So
Right?
0.2 is not replaced.
Not the way this is constructed.
Okay.
You could do this the other way too, though. You could do it where you do replace it, but we don't do that. So then you come back, the next time through, what happens?
You add a new number.
You add a new number. And so the vector grows by one element, right? Right? Then the next time through, yeah. And we're doing this by what's called indexing, right? We're saying explicitly, at this index of x, put this new value, right? That's what this tells us. At index, place, actually let's say assign that value. You okay with that? So that's how we get x to be so big. That's how x becomes 101 values. Oops. Right, that's how we get all these values. And you're absolutely right. The first column, if you look right here, it's 0.2, right? That's exactly what we gave it.
So in this situation, would you be able to use like some little asterisk that causes this column to turn into?
No, I don't want to. I mean, let's talk about that as a second possible way to solve this. Okay.
let's think about this from an algorithmic perspective to see if, okay. There are two ways to solve your problem. Maybe a million ways. There are two big ways to solve your problem, right? One is it requires us to work with matrices. Okay?
Which is the direction I was going in, right?
That's right.
Yeah.
So let's hold off on that. The second one is to think about, could I rearrange this algorithm so I can pull this off without going to matrices? Okay? Now, I'm gonna turn the light back on, and let's see if, this is where I'm not a big flowchart person, but I think flowcharts can be handy for stuff like this. So let's think about this for a flow. Is it time for a break for this? Let's do a flowchart real quick, okay? It'll take a break and we'll come back. What I want to do, I'm just going to draw what the flowchart looks like for this piece of code as it is, okay? It's like this. Define some stuff. Can you guys see that? We need a new pen.
Yeah.
Is that better or worse? Define stuff, right? Then what do? We set R. Right? Then we calc all values for that R. Let's say all X values for R, right? Then what do we do after we've calculated all the X values for one of those R's?
What we're trying to do
Wait, no, let's see what we're doing right now.
assigning it
So,
to something.
hold on. Okay, sorry. Before we even got to that. So then what we do is we go back and we set R again, right? Okay, we do this, and then we do this, whatever, 7 times, right? Let's add one thing here to be more specific. Have we done all R's? And if you say no, then you go do the next R, right? And if you say yes, you've done all the calculations, right? And now, ideally, Jorge, I think you were probably going to end up to a place where you wanted to maybe even put these subplots in a for loop, right? So that would look like, would you set R again?
Yeah.
Set R, plot X for R, okay, so let's just talk to this real quick, okay? So what do we have? We define a bunch of stuff. Easy. We set a value for R, we calculate all the X values for that R. If we have some more R values to work with, we go back up here, we set a new value for R, we calculate all the X values for that R. Do we still have some more R values to work with? Yeah, go back up here. How many times are we gonna do this? 7 times, right? Because we have 7 values for R. Perfect. We're finally done. We go over here and we say, okay, set R, do the visualization. Do we have more values for R? Yeah, go back to the top, right? That's kind of the vision you had, right? Perfect, great. So let's take a break. While we're in our break, think about how can we change this algorithmically so we can stick with vectors. Okay, take a break. You guys all deserve it. Or you look like you deserve it. Is anybody going over to Cloud to get coffee? I'll join you. Oh, Cloud. We are in Cloud.
Yeah, you are. Yeah.
Oh my God.